All right. So let's break this down and take a look at example 2.14, excuse me, and see how to use these laws. Okay. Now, in this example, it's going to take a little while to kind of flush it all out, but at the same time, once you get the hang of this, I think it'll make life a lot easier. Right. This is something you can do kind of mentally, and you won't have to necessarily write it all out in the future, but it'll be just something that you go through in your thought process. And so that's what we're looking for here. But to begin, and just to practice on this next assignment, there'll be questions where you actually have to write out some of the laws. Okay, just to once again practice and just make sure that you're understanding these things correctly. So when I'm looking at this, I see that I have a sum here, right? So I know that going back to here, the limit of a sum is equal to the sum of the limits, okay, of those functions. And so basically, I can say, instead of writing it like this, I can say, okay, well, this is the limit as x approaches -3 of 4x plus the limit as x approaches -3, excuse me, of 2. Okay, so basically, I just broke these two the two components of that sum into their own limits, right? Now, this one we know how to do, right? We know that the limit of a constant is that constant, right? So we know that one. But this one we don't exactly have anything for yet, right? And so what I'm going to do is I see that I'm multiplying by a constant here in front. So what I'm going to do is I'm going to bring that constant out and into the front of the limit, just like we can see here for this one, right? Constant. And so if we have a constant here, then we can bring that out to the front and it ends up in the front of the limit, and we can just take the limit of the function itself, right? So that's what I'm going to do here. So I'm going to say on this next step, I'm going to say 4 times the limit as x approaches -3 of x plus the limit of 2 as x approaches -3. Okay, and so now these are all ones we can do, right? This one is going back to this one here, right? If I have the limit as x approaches a of x, I get a, right? And so here we have that, right? So it's going to be the limit of x as x approaches -3 is just going to be -3, right? And then I have this 4 that I'm going to multiply by it, plus, and then the limit of 2 as x approaches -3 is just going to be 2, right? And so now I have a pretty basic expression that I can just simplify using PEMDAS, right? So I'm going to multiply first. 4 times -3 is -12, plus 2 is -10, right? So this overall result is going to be -10. All right, now the question may ask you to state the limit laws that you used. Okay, so here this was the sum law of limits. Okay, you can just put sum law. Okay, and then this to go from here to here was the constant. Let's look at it. Constant multiple law. Okay, and you can abbreviate. So we'll just put constant multiple law. Okay, and then these ones you don't have to show these ones. These ones are just the basic laws, and we've dealt with those before, so you don't have to show those ones. Okay, so just show the ones that are on this list that you've used. All right. Now remember, another way we could have done this is we could have graphed it. We could have made a table and plugged in values like negative 3.01, negative 3.001, negative 3.0001, and then we could have plugged in values on the other side like negative 2.9, negative 2.99, negative 2.999, right? But this is hopefully a more efficient way to do it. And when you're looking at this, you don't necessarily have to write all this stuff out in the future. Once again, it's just going to be part of your thought process to say, okay, well, I'm just going to take the limit of this and the limit of this and then add them. And the limit of this, I can just take, I just know I'm going to plug in this value for x, and then I'll just have to multiply it by 4, right? So it'll be 4 times negative 3. And then I'm just going to, the limit of this is just 2. And so I'm just going to add those together, okay? All right, now let's take a look at this one. This one's got a little more going on. And so this is a quotient that we have here, right? So we know that this one here, the quotient law, says that the limit of a quotient is equal to the quotient of those two limits, right? As long as the denominator limit doesn't equal 0. So let's try that out. So let's set it up. And so we'll start with, I'll just put quotient law is what the first one we're using. So we're saying the limit as x approaches 2 of 2x squared minus 3x plus 1 over the limit as x approaches 2 of x cubed plus 4. Okay, so there's the quotient law. Now, in this numerator here and in the denominator, I see I have sums and differences, right? So what I'm going to do is I'm going to break this up into 3 limits, one for this, one for this, one for this. Okay? So I'm going to say the limit as x approaches 2 of 2x squared minus the limit as x approaches 2 of 3x. I already have the minus here, so I don't need it to be negative. And then plus the limit as x approaches 2 of 1, right? And so if we want to label these, this is the difference law, because we're subtracting, and this is the sum law, right? Okay, and then on the bottom we can do the same thing. We can say the limit as x approaches 2 of x cubed minus or plus the limit as x approaches 2 of 4. Okay, so I'm just breaking this up, and that's the sum law. All right, now kind of like the last one, this one we're good with, right? This one and this one, we're down to a point where we know how to do those using our basic laws, right? I know this is going to just be 4 and this is going to just be 1. Okay, this one we can use our constant, right, and bring that to the front. Okay, and actually we can do that with this one too, right? So we can use the constant laws there. So let's kind of write in what we have so far. So we're going to have 3 times the limit of x squared as x approaches 2 minus, or excuse me, I'm sorry, I put the wrong number there. This should be a 2. All right, and then here should be the 3. 3 times the limit as x approaches 2 of x plus the limit as x approaches 2 of 1. All right, all over. Now, on the bottom, what I'm going to do, oops, this should be a 2. All right, now on the bottom, what I'm going to do is, this is x cubed, right? Now I know I have a power rule right here, right? The power law for limits. It says if I have f of x to some power, I can make that the limit of f of x and then raise the power on the outside. So that's what I'm going to do on this one. I'm going to say the limit of x as x approaches 2, and then I'm going to put that to the third power. Okay, so I'm basically taking this exponent and putting it on the outside of all that. Okay, and that's so that we'll call that's the power law, and then we did the constant multiplication law, or the constant multiple law, I should say. All right. And then the last thing we can do the same thing with this. Let's just do it right here. Just so we don't have to rewrite everything, right? So we use that for this one and for this one. Okay. All right. So now we can start plugging in some values. So I know that this is 2, right? This right here is 2. This is 2. This is 1. This is 4. And this is 2, right? So and those are our basic rules. So we don't have to label those. But anytime we have a limit of a constant, we get that constant. And that's true there and true there, right? And then anytime we have the limit of x, we just get whatever that value that we're approaching is, right? And that's what all these are, why all those are 2's, okay? All right, so now let's add those other values in front. Like I'm going to add the constant there in the front. So it'll be 2 times 2 squared, right? So I put this in there. Minus 3 times 2, so I put this in there. And then plus 1 all over. And then here I have 2 to the 3rd power plus, and then just regular 4. Okay. So now we have an expression that we can just use PEMDAS to simplify. So here, exponents first, that'll be 4. 2 times 4 is 8. And here, negative 3 times 2 is negative 6 plus 1. And the bottom 2 cubed is 8 plus 4. So we know that's going to be 12. So we end up with, let's do it over here. 8 minus 6 is 2 plus 1 is 3. And then 8 plus 4 is 12. 3 over 12 is 1/4. All right. So like I said, in the future, that we're going to find this will be something that we don't have to write out and be as meticulous or just kind of, we won't have to be as explicit about all this. We'll be able to kind of do this mentally, but it is good to practice and know kind of what laws you're using and get them into the point where they're second nature, right? Where we can just once again, just kind of think through this and be like, oh yeah, I'm going to do this, I'm going to do this, I'm going to do this, I'm going to combine them together, this and this, combine them together, and hopefully that'll become something that you can do very efficiently. And remember that these laws that we're using kind of take the place of having to use a table or a graph, and so once these become very efficient, these will take the place of those other things and make life easier for us.